All right, and welcome back to the One Class stream. Again, my name is Joey. I'm going to be your math teacher for today. And what we're going to do is we're actually going to start with something new. We're going to start with something a little bit different than our traditional lecture kind of style, where I go over specific math concepts from the pre-calculus or the algebra 1 curriculum in the US. And if you were tuning in into the chemistry curriculum for the Ontario curriculum for grade 11, grade 12, we're going to do something, we're going to transition to something very, very different. And what that is it's not actually quite that different from what we're doing before. But what we've at One Class compiled is that we compiled a bunch of frequently asked questions with in terms pertaining to the topics of like algebra 1. There's some pre-algebra questions, topics in algebra 2. Geometry is a big one as well, and pre-calculus. And then for the Ontario curriculum, we did a lot of grade 11, grade 12 chemistry questions as well as any general science. So basically what we're going to do in these next couple streams is that I'm going to look at your questions that you've submitted, and then I'm going to look at the solutions that are being provided by specific tutors all over the world internationally. And what we're going to do is we're going to verify these solutions together. So what we're doing is we're going to you can feel free to ask any questions on the stream as well. But what we're doing here is we are going to look at each question. We're going to, I'll give you some time to think about this question yourself. And what we're going to do is we're going to solve it together. And I'm going to walk you through the solution that's being provided for one class. And what we're going to do is we're going to verify together if you deem the solution is correct, or if it's incorrect, or if it needs a little bit of improvement in terms of their communication and whatnot. And hopefully what this will help you to do if you're a student at home is I'll be able to teach you the specific concept in itself within the question, but also you'll be able to kind of walk through the solution as if you were doing it yourself. And what that does is that helps minimizes mistakes when you're in an assessment type situation, in a test atmosphere or environment. What you're going to do is you're implying these skills that are problem solving. You're going to apply these problem solving skills, and you're going to catch your own mistakes before you even do them. And that's kind of the goal of this stream here, to help you learn the concept through frequently asked questions, so we reach a broader audience. So without further ado, basically, let's get started. What we're going to do, we're going to start with many of these questions are going to be probably if you're from Ontario tuning in, probably about in the grade 8 or grade 9 curriculum. So more so in pre-algebra or algebra 1. And I compiled a lot of questions, and we're going to answer those questions within the next hour. And also, if you're going to tune in again at 12, within that hour as well. And then I'm going to slowly make my way across the curriculum. So I'll slowly advance to like geometry, and there's some geometry questions today as well, and then maybe algebra 2, and then some pre-calculus questions. But I found that a lot of these questions were more so just for the geometry and for in the algebra 1. So hopefully I'll be able to kind of answer these questions, and I'll be able to walk through the solutions with you, and that's kind of the goal here. So again, if you're tuning in for the first time, my name is Joey. I'm going to be your math teacher or math tutor for the session. I come from a background of being a secondary school teacher, specializing in subjects such as science, chemistry, and also mathematics, and music as well. And my goal in the future is actually I'm qualified to be a teacher just in a couple months. So I'm hoping to teach in a classroom, and I'll be hoping to teach these subjects as well. So that's kind of my background coming into this. If you're tuning in for the first time, thank you for watching. And without further ado, let's get started on. We're hopefully going to do 10 questions per session, so per hour. So approximately about 6 minutes per question, or maybe a little bit less, depending on how rigorous the question will be. And hopefully, throughout the stream, if you have any questions, let me know in the chat. If you're in the chat, maybe wave hi as well. And yeah, let's get started with today's first problem and first 10 problems that we're going to do today. So what I have today is I have a question here. So again, I'm in the One Class kind of a portal here. And what this student is asking is asking how many yards are in a 1/4 mile, or how many yards in 1/4 mile are in 1/4 mile. So let me write that down on my little board here. So it says here how many yards in 1/4 mile. And what you're going to do at home is, if you're tuning in for the first time, Again, what I usually do in my streams is that I give you about a minute or so to think about this problem yourself, and then right after, I'm going to kind of walk over the solution with you. I'm going to scroll down, walk through the solution, and we're going to do it together as well. And what we're doing is we're hopefully comparing my solution and their solution, and hopefully those two would be correct, or maybe the solution might be incorrect or whatnot. And what we're going to do is we're going to try to improve on these solutions. And that's what how many yards I'm going to write are in a one quarter mile. So that's going to be our question for today. That's our first question. And this kind of brings up this topic of like pre-algebra. We're learning dimensional analysis, or grade 8 measurement if you're in the Ontario, if you're tuning in as an Ontario student. So basically, it's asking how many yards are in a quarter mile, and this is specifically the imperial system, right? We have the metric system with meters and whatnot and centimeters, but this is the imperial system. So it's looking at yards and miles and foots and inches as well. So this is the imperial system. So take a minute to look at this question, and afterwards we're going to solve it together. So I'll give you a minute to do so. Again, how many yards are in a 1/4 mile is kind of the question here. How many yards are in a 1/4 mile? So maybe I'll give you a little hint here. So 1 mile. So 1 mile equals, this is 1,760 yards. So using this conversion, what we can do is we can solve for our problem. So this is kind of our equation here. Actually, I won't box it. But that's kind of, we're using this to solve for our question here. So again, about 30 more seconds left to kind of like look at this problem and approach it. I'm just going to check if yeah, it's 1,760 yards. Cool. Again, I'm from Ontario, so it's a little bit harder for me to, the imperial system is not something I'm like super familiar with. I'm more familiar with metric systems, so like meters, kilometers, centimeters, millimeters. But again, if you're tuning in from the US, again, you can use the imperial system, right? So I'll use that as well. Okay. So I hope you got enough time to kind of think about this question. Again, it's asking how many yards are in a 1/4 mile. So in the imperial system, again, this is the imperial system. So again, yards, miles, foots, inches, pounds, all that stuff is part of the imperial system. So you use that in the United States. And then what we're doing here is we're looking at this question again. How many yards in a 1/4 mile? Oh, this is question 1. I forgot to label this question. I'm sorry. And it's saying, and I told you that 1 mile equals 1,760 yards. So what we can do is, if I were to solve this problem, I'm not going to look at the solution on the left, but how I would approach this problem is how many yards in a 1/4 mile. If I'm using this kind of equation to help me solve for it, what I can do is I can take this 1/4 and multiply it to both sides. So how I would do that is I would do 1/4. So what if 1 mile equals 1,760 yards? Then I can say 1/4 mile, or 1/4 times 1 mile would equal 1/4 times 1,760 yards, right? And that's how I would do this problem, or how if you were in a pre-algebra kind of course or grade 8 measurement course, this is how you would do this problem here. So it's asking how many yards are in a 1/4 mile. I would multiply both sides by 1/4. And what that does is, I'm actually not changing the equation. Again, I'm multiplying the same thing by both sides. Remember, in equations, I'm allowed to do that as long as I'm doing the same operation to both sides, right? And then what that's going to give us is, I'm going to have on this left side here, I'm going to get 1/4 mile, which is what we're solving for. So 1/4 mile equals, it says 1/4 times 1,760. So what I can do is I can use a calculator and solve for that, and I can plug in 1/4 times 1,760, or I could use this old-fashioned long division, right? So I have 4 here. So what I can do is I'll solve this, I guess. So I have 4 times what equals closest to 17 would be 4. So 4 times 4 here is 16. Bring down the 6 here. 17 minus 16 is 1. Bring down the 6 is 16. and then it'll be another 4 here. I'll have to make some room here. 4 times 4 get a 16, minus 0 is 0, 0 bring down 0. 4 times what equals 0, 4 times 0 equals 0. And that's going to be our answer. For 440 yards would be our answer for this problem. So 440 yards. And again, you don't have to do the long division. If you have a calculator at home, you just plug in whatever 1,000. I have Casio FX991 here. I'm plugging in 1760 divided by 4, which is again 440. So that's correct. So I'm just gonna erase this because I don't know if you still do long division. So we have our answer here, right? Our answer here is 1/4 mile equals 440 yards. And I'm going to highlight this in blue. And what we're going to do now is we have our solution. What we're going to do is we're going to check it with this student's solution. It comes from Columbia University. So very, very well-known university here. So we have our answer. 1/4 mile equals 440 yards. And what we're going to do is we're going to scroll this solution. So it says here, they wrote, yards and miles are units of length. That's good. We're looking at units of length, right? How long or how far something is. Some common lengths, units of length from smallest to largest are these ones here, right? So we have 1 to 6, there's a mixture of imperial and metric systems, which I personally don't really like. I would actually keep these units separate, because you have a metric system is much easier to use than an imperial system, in the sense that you're only moving by factors of 10 or multiples of 10, sorry. And what they did was they actually did a conversion table. So they actually put one side is the length, units of length, and then the other side is the kind of numbers or conversions that you would use to go from one thing to another. So where I got 1 mile equals 1,760 yards, they put here. So 1 mile in this case, I can't highlight it, but 1 mile here equals 1,760 yards. 1 yard would equal 3 feet. 1 feet equals 12 inches. 1 inches equals 2.5 centimeters, and then so on and so forth. I'm personally not the biggest fan of these tables, just because it kind of gets confusing, because if we move back up, again, I'm multiplying if I move down, and I'm dividing if I move back up to get to a smaller number. So I want to say I'm not the biggest fan of this kind of approach to this problem, just because it does rely on kind of brute memorization to memorize these numbers, memorize these tables. What I usually do is I kind of memorize if I were to do unit analysis and unit conversion, I kind of memorize these problems here. I memorize 1 mile equals 760 yards, or I kind of just focus on like these numbers instead. The units you can kind of infer by yourself, like 1,760 yards, it has to be a mile, right? There's no way that something that's like that far or that long could be a foot or an inch, right? So that's kind of logic. I'm using logic to kind of also memorize this as well. But in this case, the student choose to use a table, which, okay, that's fair. That it's not wrong by any chance, but it's just like I would prefer another way to use the table, but that's totally fine. That's probably my personal preference as well. So what they did was they actually did the exact same thing as me. So how to memorize the table: moving upwards, quantity increases, so I multiply, that's good. Moving downwards, it's decrease, which is awesome as well. And then so again, they're using this table to solve this problem, right? How many yards are in 1/4 mile? So they use the exact same thing as me. I wrote 1 mile equals 1760 yards. 1/4 mile equals, and then you would multiply both sides by 1/4. You get 440 miles in 1/4 of a mile. So this is good. I like this solution. This solution is not bad. What a lot of students would also choose to how to approach this problem would be using this concept of dimensional analysis. So we're crossing out units in order for us to, we're basically crossing out units. So how we would do that would be, if you have 1 mile, so 1 mile, so I would have 1 mile over 1 mile. I'm going to multiply that by 1,760 yards per mile. And then I would multiply that by 1/4. So this is the concept of dimensional analysis. What I'm doing is I'm changing my units as I move, as I do my operation. So this is a tactic employed a lot in physics. So what we're doing is 1 mile times 1 mile. So we're crossing out these units here. Or sorry, this unit doesn't exist here. It's just 1 mile. 1 mile. So what I'm doing is if I'm multiplying this, my miles cancel out here, and I'm left with 1 times 1,760 times 1/4, right? Because I'm solving for 1/4, and it would give me the exact same thing. It would give me 1760 divided by 4, and I would still have yards over here. And if you actually plug that in your calculator, you get 440 yards. So it's so this is another tactic to use. So if you want to use this dimensional analysis to solve for your problem, again in gradient measurement, you probably would use something like or in pre-algebra, you'd probably use something like this, like and the solution that's provided for us. But in higher level mathematics, you would probably use something like this, because what we're doing is we're keeping track of our units as well. So this the solution. What I can do is I can verify the solution. I'm going to say that this is a good solution or great solution, and great step-by-step process. I would have liked something with dimensional analysis, but it's totally fine for a pre-algebra course. So I'm going to say great solution and great step-by-step process, and I'm going to say solution is correct here. That's awesome. We're 1 for 1 here, and then we're going to move on to our second problem. So that's kind of the format of what we're going to do. What we're going to do in these couple of questions. I'm ideally going to go through 10 questions here. So that's kind of the goal as to what we're doing. So I'm going to move down, and then we're going to do question number 2. So question 2 states a 26 feet long painting is how many yards? So I'm going to do that, and I'll write that down. So a 26, and this little dash here means feet, right? Go again. If someone's a 6'3", I would write 6 foot and then 3, right? So this here means feet, and this here means inches, right? So that's just a little side. So I'm going to erase this. So 26 feet. I'm going to write, maybe I'll just write feet here. Feet painting is how many yards long? So again, take a minute by yourself and think about this problem. It's very, very similar to our problem that we had last question. So again, we're talking about this concept of measurement and this concept of pre-algebra. So pre-algebra measurement and unit conversions. And again, we're still in the imperial system. And I'm going to give you a hint here. So 1 yard, and they actually give you a conversion formula here, but this is saying 1 yard equals 3 feet. So 1 yard equals 3 feet. So again, how would I solve for this problem? 1 yard equals 3 feet. So, or I can say 3 feet equals 1 yard, right? Equals 1 yard, depending on how you look at the problem. Again, okay, so take a moment to think about this problem. How would I convert from feet to yards? So from feet to yards is what I'm doing here. So a 26 foot or 26 foot at 26 feet, 26 foot. I don't know what the plural was. 26 foot painting. I think I should write foot here. Foot painting. Painting is how many yards long? Again, take a minute to look at this problem, and then we're gonna walk through the solution together. So again, we know that sorry, we know that our conversion is feet to yards, right? So that's what we're doing here. We have 26 feet or foot. So, sorry. My throat's kind of raspy. I don't know why this morning. Sorry, guys. Okay. So what we're doing here is we're converting from feet to yard, right? So from feet to yard, what would could the conversion be? So if I had 1 yard equals 3 feet and 3 feet equals 1 yard, what I could also write here is I could actually divide both sides by 3 to get another conversion here. And I'm going to do this in blue. So if 3 feet equals 1 yard, then 1 feet or 1 foot would equal, I would have to divide both sides by 3. I'm dividing both sides by 3 in this case. So 1 foot would equal 1/3 of a yard. And once I have that, this problem becomes very, very easy. So once I have this, I had to move, again, I'm dividing both sides by 3. So both sides by 3 to get this problem. Like 3 divided by 3 is obviously 1, and 1/3 here. 1 divided by 3 is 1/3, right? So 1 foot equals 1/3 yard. And then what I would have to do is I would just plug in here this number here, 26, right? A 26-foot painting, I would plug it in for this side here. So I'd multiply both sides by 23, right? So I have 1 foot. So I would have 26 times 1 foot here equals, and then I have 26 times 1/3 of a yard, right? So then I would have, in this case, I would have 26 feet would equal 26 times 1/3, right? Or I can say 26 divided by 3, right? And that would give me, let's see, 26 divided by 3 would give me, this would be 8 2/3. So 8 2/3 yards. Or I can say, if I want to put it in decimal, it would be, or I can say here, it's 8.66, and then actually this is a repeating number here, yards. So 8.66 yards, or 8 2/3, or if you want to put it in an improper fraction, that works as well. 26.3 yards. This works as well. So that's gonna be my answer for this problem here. And I'm gonna let's walk through the solution together. So it says here yard to feet conversion is 1 yard equals 3 feet. That's good. That's what I wrote here, and actually that's what I based it off, because this is a correct conversion formula. Or you can say 1/3 equals 1 feet equals 1/3 yard. That's what I did here as our first step. So 26 feet equals 26 over 3 yards. That's awesome, which equals 8.66 yards, which means a 26-foot painting is equal to 8.66 yards long. So this is a perfect solution. This is exactly what I would have done as well, and that's what I showed you here. So I'm going to write here, this is a perfect solution, great step-by-step analysis. I'm going to write that, and I'm going to say the solution is correct. So that is awesome. That's going to be my second question for today. That's sweet. So again, these are all measurement or kind of geometry kind of questions, probably usually being taught in grade 8 or grade 9 math, and that's what we're going to start with for today. Okay, this is question 3. It's asking which undefined term is used to define an angle. So this is more of a kind of a concept kind of question, or math terminology question. So let's say here, which defined term is used to define an angle. Okay, so this is a geometry question. If you're a geometry student, this is kind of what's familiar to you. So this is a geometry question. Or actually, I think it's a pre-algebra question as well. I think it's both pre-algebra, and I think this is actually more so a pre-algebra question than a geometry question, just because what we're doing is we're looking at kind of points, rays, planes, lines. We're looking at all these concepts. So take a moment to think about this question. Again, what defined term is to define an angle? So maybe first define what an angle is. So what is an angle? So what is an angle? So let's define. So here are the steps for if you're listening from home or watching from home. Let's first define what an angle is, and then second, we have to know what a defined term is. Defined term, or what is defined term? Let me just ask, what is a defined term? So what is a defined term? Or sorry, this is asking what is undefined, right? Sorry, my bad. This is which undefined term? This is undefined, sorry. I'm gonna erase this. This is what is an undefined term? Let's take a moment to think about this, and then we're gonna move on. So which undefined term is used to define an angle? It's very, very confusing how they phrase this question. But which undefined term is used to define an angle? Then they're given 4 options: point, ray, plane, and line. So how would we solve this problem? How would we solve this problem? So this is actually kind of a tricky question, and it's a tricky question because first let's define what an angle is. So an angle, if you remember from pre-algebra, is kind of two rays connected to a vertex. So how we do this is, remember what a ray is I have a point here, and I have a ray extends only in one direction here, right? And if an angle, I would have something like this, right? I would have like a, for example, like an angle that's less than 90 degrees would have two rays. I have two rays that are connected by this here is a vertex or a point. You can say this is a vertex because they meet together. And then this here, I can label it theta or something. This here is our angle, right? Again, this is kind of what we've been, what we're familiar with. So this is so this is an angle. So now we have to ask ourselves, what is an undefined term? An undefined term. So an undefined term means that it's just from undefined terms, we can define all our terms in geometry. So let me just walk through these four things first. Let me go through these four things. So what's a point? So a point, again, is just kind of one singular coordinate in space, right? So point here looks something like this. It tells us one coordinate in space. Could that be able, does that give us information about an angle? Not necessarily, which means point here, A, is wrong. So I'm going to break this down. B here is a ray. A ray here is what we're looking for in this problem here, which is correct, right? So again, a ray is one direction and it's going towards something, right? Which is good. So ray could be an acceptable answer, but I'm going to go back and improve on my answer after. C here is a plane. And what is a plane? A plane is something that's kind of, it's in two dimensions. So it has no width, or it has a width of an infinite length, an infinite width, and extends infinitely in two dimensions. So for example, in a XY plane is something we're familiar with. This is X, this is Y. This is a XY plane. So this helps us determine, we plot a lot on something called the Cartesian plane, so an XY plane, which is cool. But this doesn't help us find an angle, right? Angle is made by two rays, right? And then D here is a line. And a line is different from a ray in the sense that it's saying it's going from one point and it has a defined endpoint here. So of all these four things, I can say that A is wrong. And C is wrong. But B and D could be possible answers because both of them, if I have a ray like this, I could have also a line that goes like this, right? I could have something like a line that goes like this and a line that goes like this, and this would still make it an angle here, right? So again, line and ray are both correct answers, but we have to go look back at the question. What is an undefined term? When we talk about undefined terms, there's only three undefined terms that you should be familiar with. So undefined terms such as, so point is an undefined term, a line is an undefined term, and a plane is an undefined term. So these two these options, so these are all undefined terms. And when we talk about undefined terms, is from these terms we can define other terms such as array. Array is a defined term, right? This array here is a defined term because what array is made up of one point and a line, right? And that's what it is. It's made up of one point, and then we're extending this line infinitely in one direction, right? It's made up of one point here, and then what we have here is this is a point, and this arrowhead just means like it's a line, but it's just extended infinitely in one direction, right? So it's extended infinitely. That's all it is. So from that term, from a point and a line, what we can do is define array. So in this case, this is array is a defined term, not an undefined term. So this is also the wrong answer, which means the line, because it's an undefined term, is our answer here, and that's going to be our answer for number 3. So let me look at their solution here. So option D is true. That's awesome. That's great because our solution was option D. They have here, these are two lines to define an angle. We have two straight lines that intersect each other. Okay, that works. And figure 1, we have, okay, cool. So they drew a diagram here. A is false, B is false. Array is a defined term, right? That's good. I would have liked something if they were to kind of go more in depth as to how they define array as a defined term. C is false, D is true, hence the answers. I like this solution. I'm going to say good solution. I maybe I should have, maybe I'm going to also write here, could also expand on how we define. I'm going to put this in quotes to not confuse the person. Define array as a defined term, rather than just saying array is a defined term. Like, why is it a defined term in geometry? So could also expand how we define array as a defined term rather than just saying defined term. And I defined it as array equal is a point and also a line extended infinitely in one direction, made up of defined terms. Or this is an undefined term, right? Which is an undefined term. So again, array is a defined term, right? Made up of defined terms. Yeah, cool. Awesome. Or sorry, this is undefined terms. Okay, cool. That's going to be our answer for the solution. I'm going to mark our solution as correct. Sweet. So it's our next question here, number 4. So we're about half an hour now. So maybe I'll pick up the pace slightly, but I had a little buffer because of introductions and whatnot. So that's okay. We're still on track. So number 4 we have, this is what is a square root of 64? What is the square root of 64? And again, we're not really using we can't really use the use the calculator here. I'm assuming we can't use a calculator. So again, this is we're working with pre-algebra or algebra 1. What we're working with radicals actually. So algebra 1. So I'll give you a minute to think about this problem here. What is the square root of 64? So again, a minute to think about this, and then we are going to look at the solution together. So what is the square root of 64? There's kind of 2 ways to think about this question, and I'm gonna do both ways for you as well. So what is the square root of 64? Okay, so let's look over this problem. I'm going to do this in blue. Square root of 64 is you look at something like, I'm going to draw it out mathematically. So this is actually the square root of 64. So what we can do with these problems is I can employ a guess and check rule, or I can employ something called a kind of a synthetic division kind of rule for radicals. So I'm going to do guess and check first, because that's usually what I would do first to figure out if it's a perfect square, if the square root is a whole number. So how I would do this, I would do kind of a trial and error. And what I would do is I would look at my squared value. So for example, 1 squared, and I would see if it would equal 64. So equal 60 in the square root. So 1 squared would equal 1. 2 squared equals 4, because 2 times 2, sorry, I wrote 24, would equal 2 times 2. 3 times 3, or 3 squared, would be 9. 4 squared would be 16. 5 squared would be 25. So 5 times 5, right? It's just the number multiplying by itself. 6 squared is 36. 7 squared is 49. And 8 squared is 64, right? 8 times 8 is 64. So actually in this case, our answer is, I can actually simply just do square root of 64 equals 8. And actually that's my solution. So that's actually a guess and check that I would sometimes use if I were to look at square roots that are maybe like below 100, just because it's a quick and easy way to check whether or not it's a perfect square, right? So again, 8 times 8 or 8 squared would equal 64. So that's gonna be my solution for this answer. Okay, so this is a guess and check kind of solution here. Guess and check. So that's one way of looking at it. Another way of looking at it would be kind of breaking down the square root in terms of prime numbers or smaller numbers. I would have to say. So again, this here is where it's actually very, very similar to the solution here. So I'm actually gonna walk you through the solution while I do this problem here. So again, I like how they did the concept. So square root of a number n is number multiplied by itself gives a number n, which is good. Square root of 64 can be calculated by taking out the factors, which is good. So when we take out a factor, what do we mean by that? What we can do is from this factor, what we can do is what they did was they did something called like they thought of this division as a long division question. So they're dividing 2 out of 64. And then what they can do is, if you take 2 out, 2 times what equals 64? 2 times 32 is 64. And then they take out another 2, which would be 2 times what equals 32 would be 16. And then 2 times what equals 16? 2 times 8 equals 16. They took out another 2, and then 2 times what equals 8 would be 4. And then 2 times 2 equals 4, right? So that's good. So sorry, and this 2 times, oh, I missed a 4 here. 2 times 8 is 4. I missed a 4 here. And then 2 times 2 equals 4, right? I'm left with 2. And then I have 1, right? Which is, and 1 times 1 is 1, right? So we're good. And now what they can do is they're going to rewrite this number as in terms of these factors. So 2 times 2 times 2 times 2 times 2. So 2 times 1, 2, 3, 4, 5, 6. So this would be, so they're writing out 64. So this number here as a factor of these guys. So I'm going to do some blue. These guys here. So I'm going to do this as, so they wrote 64 equals 2 times 2 times 2 times 2 times 2 times 2. Or you can say that this is 2 to the power of 1, 2, 3, 4, 5, 6. 2 to the power of 6 equals 64, right? So that's good. This is 2 to the power of 6 equals 64. Or you could rewrite this as, you could say it's, how they wrote it here would be, or sorry, this is a square root of 64. And this is square root of 64, right? And what they could do is they also broke this down into 2 to the power of 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2, right? And what we can do that through our exponent laws, right? 2 plus 2 plus 2 equals 6. So I'm adding exponents when we're multiplying them together, right? So that's cool. That's what they did here. And then what they did was they canceled the square roots with the squares here. So because the square root and taking it to the power of 2 is the opposite operation, so that's what they did there. And they're left with this 2 times 2 times 2, which is 4 times 2, which is 8. So again, this here is also a very, very valid solution, which is awesome. But what I did here was I did a guess and check. So both of these questions work. And I like here step 2, since squaring a negative number. Since on squaring a negative number, a positive value is obtained, hence square of negative 8 will also give us 64. That is also correct. So basically what they're doing here is that they're saying that positive 8 squared is 64. But if I square negative, it would also equal 64. The square of negative 8 would also equal 64. So this here is also a solution. So the solution here is plus or minus 8, which is our solution here. And I actually forgot to put plus or minus 8 in my solution. So that's actually so good on the person from Colombia to kind of catch that. A lot of students, again, even like myself, we always forget the minus here. So plus and minus 8 is also our solution. So I'm going to say here, this is a perfect solution because they broke this down very, very, very nicely. It's a perfect solution. Great step-by-step analysis. Sweet. I'm going to move slightly faster now, just because I do want to cover everything we have today. We have about 5 more questions to do. So this is number 4. Sorry. I'm going to move slightly faster. So this is number 6. Sorry, this is number 5. Question 5. So it's asking us, what is the additive inverse of the polynomial? And they give us that, right? So our additive inverse of negative 9xy squared plus 6xy squared minus 5x cubed. So they're asking us, what is the additive inverse of this polynomial function? So I'm going to give you, again, a minute to think about this problem, and then we're going to take it up. So let's do that. A minute to think about this problem. We'll take it up. You can also look at the solution they provided, and you can kind of see You can see, you can kind of guess for yourself or know for yourself, is this solution correct or incorrect? So let's do that. Give you about 30 seconds to look at this problem, and I do have to move forward, so maybe 30 seconds to move this to look at this problem, and then we'll move forward. So the additive inverse of negative 9x y squared plus 6x squared y minus 5x cubed. Let me define a couple things. When we talk about additive inverse, so the additive inverse is simply just setting it to 0, and then what we're going to do is we're going to move all the variables to the other side. So when I say additive inverse, so let's say here additive inverse of y. So if I say what is the additive inverse of x? And when we say additive inverse of x, I would have to set this set x to 0. So x equals 0. And what we're gonna do is we're gonna move it to the other side. So we're gonna move this to the other side. So I would get here, this would be, so 0 equals, and then I've had plus x on one side, I would have minus x on the other side, right? So negative x here is our answer. So negative x is the additive inverse of x, which makes sense, right? Because x plus minus x equals 0, right? X minus x equals 0. So with that logic, what I can do is I can actually solve this problem here. So I would just set this problem to 0. So negative 9xy squared plus 6x squared y minus 5x cubed equals 0. I'm going to set this to 0, and what I'm going to do is I'm going to move everything to the other side. So let's do that. Let me move everything to the other side. So if I have negative 9x y squared, I'm gonna do the opposite operation, and then do plus 9xy squared to both sides, right? So if I did that, I would get this side would cancel out, so I would get 6x squared y minus 5x cubed, and this side I'm doing the opposite operation of this, right? So this would be plus 9xy squared. Or I can leave the plus here, but this is 9xy squared. Perfect. Next, what I'm doing from left to right? So again, 6x squared y. The opposite of addition is subtraction, so I would subtract both sides by 6x squared y. The left side here becomes simply just negative 5x cubed. I would have 9xy squared minus 6x squared y. And then finally, I have negative 5x cubed here. I'm going to have to do the opposite operation, which is plus, right? So I'm adding both sides by plus 5x cubed. In this case, I'm left here with 0, which is negative, this is positive, sorry. This is 9x squared y minus 6x squared y plus, because I'm adding both sides by 5x cubed, plus 5x cubed. And that's going to be our additive inverse of this polynomial. So let's check our answer. 9x squared y minus 6x squared y plus 5x cubed. My solution matches this one. I like this one, but they didn't really break it down into, they did 0 minus minus, which is also a valid answer here. And they did 0 minus, and then they put a bracket between the entire polynomial. So this works as well because they're subtracting the entire polynomial. I chose to break it down in steps. They did kind of one step together. Perfectly fine. This is a great solution. And this is a great, perfect solution. Great step by step. Just gonna jump talking numbers. Perfect. Solution's correct. Sweet. Okay, now I am moving along. This is question 6. I have about 15 minutes, so hopefully about just under 2 minutes of questions. So hopefully I can actually solve this in time. So this is 6 here. So it says, given the triangle M and L, what is the value of cos M? So this is trigonometry now. So I'm going to draw my triangle. This is a really bad triangle. Actually, I think I'm going to rotate my triangle. Sorry, guys. I'm going to rotate my triangle, so I'm going to write it like this. Write it like this. This is my right angle here. This side is 15. This was from N to L. Right? I'm trying to look at it a different way. I'm not given this as X. I'm not given that. And then I'm finding, where's M here? N is, so I'm going to write this in blue. So N is here. The top is M. And this is L, right? Okay, sweet. Okay, so let me. So I'm gonna do this problem again. I rotated the triangle for those of you at home if you're uh, watching. So again, I have here. Sorry, this is an N. So again, given the right triangle, I'm finding what's the value of cos M. So what is cos M? So it's saying what is the value of cos M? And again, so I have M is this. First, what is this angle here? M here is this angle on this kind of top side here. So I'm looking at this angle specifically, and what I'm doing is, again, I'm doing this method of SOHCAHTOA, right? So SOHCAHTOA, so SOH. This is kind of a mnemonic that I use to use trig, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, right? So cos M, which means would equal adjacent, so adjacent over hypotenuse. And then in this case, adjacent to this angle is this side x, right? So I'm going to write x here. And then hypotenuse is this number here, which is 25. Sweet. So cos M would equal this value, x over 25, right? But what we have to do is we have to solve for x first. So how do we solve for x? So when we we can solve for x through our Pythagorean theorem, right? If I know Pythagorean theorem is c squared equals a squared plus b squared, and then what I'm doing, I already have c squared, right? My hypotenuse is already c squared. So in this case, I can rearrange the formula and say c squared minus a squared equals b squared, and b squared I'm going to say here is my x squared. So I'm just going to say, I'm going to substitute this with x. So in this case, 25 here is my c, this is a, and then this is, I'm solving for x, right? So let me solve this. This is 25, so it would be 25 squared minus 15 squared. This is, sorry, I'm doing this in black. So this is 25 squared minus 15 squared equals x squared. So I'm going to use my calculator. 25 squared is 625, I believe. 625 minus 15 squared would give me this here would equal 400 equals x squared. I would square root both sides, and then I would get x equals the square root of 400 is 20. So which means my x here equals 20. So I can say x here equals 20, which means now what I can do is I can solve for this this problem here, right? This problem here, because if I know x equals 20, cos M would equal x over 25, which means here it's x is 20, so 20 over 25. I can reduce these terms if I divide the numerator and the denominator by the greatest common factor, which is 5. So dividing this here by 5, divide by 5 here, 20 divided by 5 is 4, 25 divided by 5 is 5. So the answer of cos M equals 4 over 5 or 0.8 is our answer. So it's going to be, in this case, it would be C is our answer. And if you lo and behold, cos M equals 4 over 5. So that's a great answer. So I like how they actually used the triangle. So I actually like this better than my method here, because I'd actually redefine this as C and redefine this as A. But the math here checks out. 25 minus 400, good. Square root both sides is 20. Cos M is the value of adjacent over hypotenuse, which is the exact same thing. So C is the correct answer. Perfect solution. Perfect solution. Great use of I'm just going to great step by step again. Great step by step. Solution is correct. Sweet. Okay, that's awesome. How many time do I have? I have 10 minutes to go over how many problems? I have 1, 2, 3, and 4. Ooh, this is going to be tight. But let's do it. This is number 7. And again, you can always go back and watch these videos. They're going to be uploaded as well. This is 7. So given the right angle JKL, what is the value of cos L? So this is very similar to our problem, like our last problem here. So I'm going to maybe speed through this a little bit faster. This is 5. This is 12. And I want cos L, right? This is here is L. Cos L. Cos L. So again, cosine. Cosine here again equals adjacent over hypotenuse, right? So adjacent over hypotenuse. So SOHCAHTOA, AH is adjacent over hypotenuse. So in this case, it would be adjacent over hypotenuse. I'm going to say this value is x again, right? We don't know this value. So adjacent would be kind of this value here, right? Oh, sorry, this is L. It's adjacent to the angle L. So this is 12, which is good. And the hypotenuse is the longest side, and we don't know our hypotenuse. This is x, right? And so this is equivalent to cos L. So how will we solve for hypotenuse? Again, we use the exact same thing, and we use Pythagorean theorem. In this case, we don't have to reorganize Pythagorean theorem because what we're c squared equals a squared plus b squared. But what we have to do is we can actually just solve. We don't have to reorganize because we're solving for hypotenuse in this case. So I'm going to say this is actually I'll say this is c. So I have c squared equals a squared, which is 5 squared plus b squared is 12 squared. Again, this here is a, this here is b. 5 squared is 25 plus 12 squared is 144 equals c squared. C squared would equal 144 plus 125 would give me 169. Square root both sides, c would give me 13. Again, I'm squaring both sides together. C equals 13. So c would equal 13 in this case, and then I can now solve for my solution here, right? If I know x here, or c in this case equals 13, I'm going to erase this and put this as c. Then cosine of L equals 12 over 13. And that's going to be my answer for the solution here. And this here also gives me 12 over 13, and it matches my solution, which is awesome. So again, they used the triangles, which is great. 169, square root of that is 13, good. And then length of base length of divided by length of hypotenuse, right? Good. So adjacent divided by hypotenuse gives you 12 over 13. Great solution. Great solution. I'll just say perfect. Perfect solution and analysis. So again, very similar to what we were doing before, right? Okay, this is number 8. And 7 minutes to go over 3 questions. This is number 8. So it's given the right angle ABC, what is the value of tan A? So this is, and I'm not given any lengths here, right? So this is kind of more of a conceptual question. This is A, B, C. What is the value of tangent A? So this is tangent A here. So, and then we look at their solution here. I'm gonna maybe I'll define these as I'll define these two things here. So again, this here from A to B, this is AB. So I'm gonna do this in blue. This is AB. From B to C is BC, and then from A to C is AC, right? And that's what you're kind of familiar with here. So tangent of A equals tangent of A is TOA, right? Opposite over hypotenuse, or adjacent, sorry. So opposite OPP over adjacent TOA, right? So what is the opposite of this angle A here? Opposite of that is BC, right? So which is tangent A would equal BC over adjacent here. Adjacent to this angle would be AB. So this here is my correct answer. BC over AB will be my answer for tangent A. And this here is my correct answer, right? Tan A equals BC over AB is the required answer, right? So I'm doing a length of perpendicular. So again, it's the opposite over the length of the base, which is the adjacent, right? So that's good. Opposite over adjacent, that's the correct answer here. So again, this here is a perfect solution and analysis. Again, these are all just trigonometric ratios that you've been learning before. 2 more questions. 2 down. 2 more to go. We're 8 down now. And actually all of our solutions were correct, which is awesome. So here, which equation can be solved to find one of the missing sides of the in the triangle? So I'm going to redraw this triangle. And it's saying this here is A, this here is B, this is 12, and the points are A, B, and C, and this is a right angle triangle. So which equation can be solved to find one of the missing lengths of the missing lengths in the triangle. And I'm giving 4 options here, cos 60 for all of them, and then these are all varied, right? So I'm going to say, which means our answer has to be cos 60, right? So cos 60, and this here is our 60 degrees angle, right? Or I can say it's cos b, right? So cos b equals, again, cos b equals, again, I have here, what does cos mean? Cos is SOHCAHTOA, so ka is AH, which means it's adjacent over hypotenuse, right? So you get adjacent over the hypotenuse. So again, here I have adjacent over hypotenuse, which means cos of b equals adjacent, so which is the a here in this case. A is the adjacent to the angle divided by the hypotenuse, which is 12, right? So adjacent here is denoted by BC, or you can say here it's a divided by hypotenuse, which is simply just 12, or a divided by 12. So this here is my correct answer. A divided by 12 would give us the cos of b, or cos of 60 here. Cos 60 here. I'm going to say this is 60 as well, just to avoid confusion. So a over 12 is my correct answer, which is D. So in this case, hence D is the correct answer, which is good. Cos 60 equals BC over AB, which is a over 12. Awesome. Cos 60 implies that a divided by 12. Good. Perfect solution. And step and analysis. Sweet. All right, we are on our last question for the day. This is question 10, and we have 3 minutes to spare, which is awesome. So we are going to solve and figure this out. And again, I chose all these questions because these are all related to trigonometry, and before was related a little bit to geometry as well. So hopefully, because for the viewers at home, if you're kind of confused about trigonometry, hopefully this is a good brush up or good lesson for you viewers at home. Okay, so it's saying here, given the right angle RPQ, or RQR, sorry, PQR, sorry, I couldn't read, sorry about that, which represents the value of sine P. So sine P would equal, again, I have sine P here, so that's this angle here, I'm going to do this in blue. It's this angle here, right? So sine P equals, what would that equal? It would equal sine P is, sine is SOHCAHTOA. The SO is opposite over hypotenuse. So opposite over hypotenuse, which means in this case, the opposite of this angle is this side over here, which is, which here is RQ, right? RQ is the opposite side. And the hypotenuse in this case is PQ, right? PQ here is also the hypotenuse in this case. So RQ over PQ would be our correct answer in this case. So RQ over PQ, which means this is our answer here. RQ over PQ. Here, RQ over PQ is our answer. They said RQ over PQ, which is our correct answer as well. Sine C is the correct option. So our answer is correct. Here we're given a right angle. I'm just going to read over this here. So we are given a right angle triangle, which is good. So they redrew the triangle. We knew that sine equals perpendicular over hypotenuse. So I said opposite over hypotenuse, the exact same thing. Perpendicular is RQ, which is good, and hypotenuse is PQ. So that's correct. And then they did sine is RQ over PQ, which is the correct answer in this case, in this solution. So this is sine P. Remember, I use the mnemonic SOHCAHTOA, and then I think that's kind of taught in Ontario curriculums as well. And then what I do is I actually rewrite this in terms of the triangle here, because I have here, if you're not familiar with this, S here is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA is tangent. So opposite over adjacent. So again, this wraps up our first session of answering math questions, frequently asked questions. Again, I'm going to try to, I have to say here, perfect solution. Sorry. Perfect solution and analysis. Solution is correct.